Okay, so we're doing recitation problems. So this is the second set of recitation problems, and we're actually asked in number 1, the first question in the recitation is find the speed of light in various materials. So we're assuming that we have the index refraction. Just to remind you what the basic idea. When light goes through various materials, it actually slows down from the speed in vacuum. So we know that the speed of light, usually denoted by the symbol c, travels at roughly 3.0 10 to the 8 meters per second. Okay, so in any other material, when light meets matter, it actually interacts with the matter and slows down. So the speed of light is much lower than 3.0 times 10 to the 8 meters per second. So, for example, actually you have to know this, so the index of refraction, right? The index of refraction, this is called m, is defined to be the speed of light in vacuum over the speed in the material. So if the index of refraction, so let's assume, right, that we're told that the speed of light in some material is, let's make it easy. So let's assume that we have 10 meters per second for the speed of light, and we're told, right, that the speed of light in the new material is actually traveling at 1.0 times 10 to the 8 meters per second. And so your index of refraction is, and cross these out, I'll bring out a calculator, is 3.0. So this is your index of refraction. So if you're given an index of refraction, it's basically the ratio of the speed of light in vacuum, which is the fastest, to the speed in the material. And light interacts with matter, so it slows down when it interacts with matter. So we can actually take this equation and solve for vice versa. So if somebody gave you this equation, we can actually solve for the speed in the material as move it to the side and divide by n, so that it's c divisible by the index of the material. So a couple of little things you should be really wary about. Index refraction, notice the meters per second here, meters per second, they cancel. And so index refraction is just a pure number. So this is what we're going to be doing. So let me do some examples and of some material. So let's, for example, let's find the speed in water. Let's find H2O, speed in water. So the speed in water, right, is the index of the speed, c, divisible by n H2O. The speed of light is 3.0 times 10 to the 8 meters per second. And I can look up water, right? I just actually happen to remember it, so let's just go through it. So index refraction of water, right, happens to be 1.33. I was actually writing up the notes earlier, so I have to remember that. So 3.0 times 10 to the 8 divided by 1.33, and I'm going to bring out my calculator. And I could assume this is 4/3, right? But I'm not going to. Let's just plug it in. 3.0 exponent to the 8 divisible by 1.333 gives me 2. So 2 significant digits, so we're expecting it to be 2.3 times 10 to the 8 meters per second. So let me do another example, and let me do an example, for example, let's do diamond. So the index of refraction for diamond, I'll put C for carbon, and the index of refraction of carbon, I actually have to look this up, hold on a sec. Index of refraction, I'm looking up the index of refraction tables. It's in the notes. Hold on a sec. So the index of, it's 2.417. So we're told that diamond, which is pure carbon, is 2.417. So again, we're going to be plugging into our standard equation. So index of refraction is by definition the ratio of the speed of light in vacuum divided by the speed in the material. So we solve for the material, and so we're left with that v, speed of light in carbon. Okay, so it's 3.0 times 10 to the 8 meters per second divisible by 2.417. And I'm going to plug this in to two significant digits. 2.417 gives me a value of 1.2 times 10 to the 8 meters per second. Notice these numbers are smaller than 3, so if you did make a mistake and you multiplied, then you'd know that light actually slows down because it interacts with material. It's much like if you're, I can run through the air very quickly, but the minute I jump into the water, right, I'm interacting with water much more readily than air particles, and so I slow down. And so it's the same basic idea for light. Anyway, so let's go on to the next question. So this is question number 1. Recitation set number 2.